All right, we are back. Unit 2, day 6. Yesterday we talked about long division. Today we're going to be talking about a second type of division. But first I want to start with our warm-up today. We are on page 186 of the workbook. So you can turn to there. We're going to do 7, 8, and 9. So if you want to try those on your own, and then come back to the video and see if you got them correct. All right, this first one, it says Kieran wrote f of x equals x minus 3, x minus 7, and x plus 4 as an example of a function whose graph has x-intercepts at -3, -7, 4. What was his mistake? So obviously there's something wrong in here if they're asking us if there's a mistake. Now, one thing we can do is we can take this and actually graph it and investigate, okay, what do we see, all right, in this picture? So what do we see when I actually graph what he wrote? And he could have checked it on Desmo. So please realize that you can check a lot of this stuff there. And we notice our x-intercepts are actually the opposite. Instead of it being 4, it's -4. Instead of it being -3, it's 3. And then instead of it being -7, it's 7. So what did he do? Well, here, if we're trying to write a polynomial that has x-intercepts at -3, -7, and 4, we actually just need to think the opposite on this. All right. So basically, we can say he didn't think opposite, if you want to put that. Okay. And what he's got to do is, if you see -3 as a root, that's the x-intercept, then x plus 3 is a factor. All right. If -7 is a root, right here, x plus 7, the opposite, is a factor. And if 4 is a root or x-intercept, then x minus 4 is a factor. So this is the polynomial he should have written right here. All right, moving on to number 8 down here, same page. All right. And guys, sometimes anytime it says like this from unit 2, lesson 3, you can go back to lesson 3 to kind of see, all right, what do we learn here? All right. Now, a polynomial function f of x has x-intercepts, all right, -6, -3, and 2. What is one possible factor of it? Honestly, this is similar to the same question above. If -6 is an x-intercept, the opposite, x plus 6, is going to be a factor. So that's one of them you could have written. Okay, but what if -3 is a root or x-intercept? X plus 3 is a factor. And if 2 is an x-intercept, then x minus 2 is a factor. Any one of these factors you could have written out, okay? Sometimes in a multiple choice or select answers, they may say select all your factors. You would have to select all 3 of these as factors if these are given your roots. All right, and number 9. Okay, select all the polynomial functions whose graph has x-intercept. So again, all these questions are very similar to one another. Here's my x-intercepts. So let's think about this. I'm going to ignore this part right here for a second. So if 4 is a root, then I should see x minus 4. If -4 is a root, then I should see x plus, or 1/4, I'm sorry, x plus 1/4. And if -2 is a root, I should see x plus 2. All right, now, one thing I notice is this one has a factor. I don't see any fraction. I don't see any fractions in here. So one of the things you can do with this is actually change this, all right, and put the 4 in front of the x right there, like that. Okay, so now here's another thing. Because this is multiple choice, you can do a process of elimination. X minus 4. I got to see x minus 4. Well, this says x plus 4. So it's not that. Anything that says x plus 4 isn't going to be it. All right, same thing. I need to see x plus 2 and not x minus 2. So I can mark out this one. And I can mark out that one. All right, and then 4x plus 1. All right, now both of these have x plus 2s. Both of these has 4x plus 1, but these are both different right here. All right, now the question is select all, so just each of these could be an answer. Now, one way you could do this is you can graph it. All right, now this one we already determined, x minus 4. This is exactly what I've written. So this is it, and you can graph it and see. I'm going to go to this one, all right, f, and I'm going to actually graph this. All right, so 4x minus 16, and then 4x plus 1, all right, and then x plus 2 right here. Okay, so here Let's go look at our x-intercepts. -2, negative 2.5 is -1/4, and then 4. All right, the one in question was the 4, and these are all x-intercepts, so this is an answer. Well, why is this an answer, but I didn't get it here when I wrote it? Well, here, do you recognize something here? If you said a 4 can come out, GCF of 4, you are correct. Okay, and when I do that, I'm left with x minus 4. So sometimes you can have GCFs that come out, and it's okay to have these numbers that you multiply on the outside, okay? And if I graph the top one, you'll also see that is has the same roots as well. All right, so here was our warm-up, day 6. All right, and so make sure you know things about roots. It's going to be very important. All right, so now let's go on to day 2, unit 2, day 6. Sorry, not day 2. Unit 2, day 6, synthetic division. All right, yesterday we took a look at long division. Anything can be done by long division. Today, what we want to do is we want to take a look at something called synthetic division. Now, we can only use synthetic division when the divisor is in the form x minus a or x plus a. And what I mean by that is there's nothing out in front of this x. All right, it's a 1 actually. You won't see the 1. The coefficient in front of x is 1, like I just said, and the degree of the polynomial you're dividing by is 1. If you're dividing by something that has x squared, you're going to have to use long division. Now, here I can use synthetic division right here. All right, because I'm dividing by x minus 2. Now, here's the first step of this. All right, you want to take what you're dividing by, x minus 2, and set it equal to 0. All right, and solve. You want to add 2. So I get 2. This is the number you're going to put in a box. All right, now, what was one of the first steps of long division? All right, if you said check your exponents, you're correct. You need to do the same thing here. So here, if I start with x to the third, I need to see x squared, I need to see x, and then I need to see a constant. And so I'm good here. All right, however, now we're not going to write it. Synthetic division is a little bit easier because you're not actually going to write any of the x's. You're only going to write the numbers. So I'm going to write the coefficients right here. I'm going to write 5. Now be careful. This is a -13. So I'm going to write -13. So if you ever have a minus, make sure you put a negative. All right. Then you're going to do 10, and then you're going to do -8. All right. So here we go. I'm going to put a line, but I'm going to put something above that line. So leave a little space. Now our first step in synthetic division is drop your 5 like that. All right, now what I'm going to do is I'm going to take this number right here, 2, and I'm going to times it by 5, and I get 10. If you need to use your calculator for calculations, feel free, okay? Just have it handy, or Desmos, one or the other. I'm going to get mine ready. All right, now, the next thing we do is we add these two numbers together. -13 plus 10 is -3. All right, now we start all over again. Once you get to this point, we take -3 and multiply it by 2, and we get -6. Now again, we add these two numbers, so this gives us 4. 2 times 4 is 8. All right, and we add this and we get 0. Well, guess what? This is our remainder. And what did it mean yesterday when we had a remainder of 0? All right, what it means is this thing that I'm dividing by, x minus 2, is a factor. Now, this doesn't look like our answer from yesterday, so we got to get it, and we got to put x's back in. So how are we going to do this? Well, here we have x cubed. Okay, drop it by 1, x squared. Okay, so I'm going to put an x squared here. That's where I'm starting at. And then I'm going to put an x, and then this is my constant. And then that would be my remainder. Now, if there's nothing in front, like there's nothing in front of this 4, put a plus because that's a positive 4. All right, so what we know is when we divided by x minus 2, we ended up with 5x squared minus 3x plus 4. And since it's a factor, we can say this times this equals that right there. All right, now let's look at this next one, number 2. Okay, so we're dividing again, and yes, I can use synthetic division. The reason is I'm dividing by something that's just x minus 1. All right, it's either x plus something or x minus something. Now, Our first step, and again, this is division. They do look different, and it's okay. All right. But just know both of them are division. So x minus 1, set that equal to 0. So we want to add 1. Now, some of you may get to the point that you're like, well, wait a minute. For this one in number 1, if I saw x minus 2, the opposite 2 goes in the box. Here, if I see x minus 1, think opposite of negative 1 would be positive 1. Positive 1 goes in the box. All right, now what do we have to check? We have to check our exponents. All right, so I see that it starts with x to the 4th. All right, so it must say x to the 3rd, x squared. Oh, I'm missing something. I'm missing my x. So what I'm going to do is put 0x in here. And then I have my constant. Now, sometimes you're adding multiple zeros, and that's completely fine. All right, so here we go. I'm not putting x down. I'm just putting the number. So I'm going to start off with negative 9. Then I have a positive 10, so just put 10. I have a 7. Now, this is where I need that 0, so put 0. And then I have a negative 6 as my constant. Remember, put your line, but put a little space because we're going to put something on that line. All right, now, what is the first thing we did here? We dropped that first term, so I'm going to drop negative 9. All right, now take negative 9 and multiply it by 1, and I get negative 9. Now, what do we do next? We add these two together. So 10 plus negative 9 is 1. All right, 1 times 1 is 1. All right, and we add. So that gives us 8. All right, now 1 times 8 is 8. And we add again. 0 plus 8 is 8. All right, 1 times 8 is 8. And now when we add it, we get 2. Now remember, what is that last number? Our remainder. So wait a minute, I got a remainder of 2. So what does that mean? Our answer is not, or x minus 1 is not a factor. Okay, so now let's write our answer out with x's in it, like we had yesterday with long division. Now, again, you want to look for what was the highest degree here, x to the 4th. Drop it by 1, and we get x to the 3rd. Okay, then we want x squared. Then we want x, and this is our constant. And remember what we do with our remainder. We take this and we divide by what we're dividing by, x minus 1. Now, anywhere that I don't have a minus sign, I need to put a plus sign because all these are positive numbers right here. So I'll put pluses. And this is our final answer right there. Now, if we did this one long division, it would take us a little bit of time to do this because it is to the 4th degree and it just is a longer answer. So it's going to take a longer time. So synthetic division, if we're able to use it, is actually a quicker method to be able to do this. All right, moving on to number 3. You see that is a word problem. We can apply word problems to this. All right, so let's do that. The volume of a rectangular prism is this. All right, I'm going to stop right there. A rectangular prism, think, is a box. All right. Well, what is the volume of a box? The volume of a box is length times width times height. Okay, so what we've done is we multiplied 3 things together to get this. It says the length of the solid is 3x. So if I just draw that in there, I can write it in there. And the width is x minus 2. So find the height. So we're finding the 3rd dimension of this. Well, what do I need to do? Okay, I need to divide. All right, now I'm going to start with the 3x first. Now, this isn't like 3 plus x. This isn't like, it doesn't have a plus or minus. This is actually a 3x is actually a GCF that pulls out here. And do you realize 3, 3, 33, and 54? The GCF is 3. And if you didn't, what you could do is you could take Desmos. And remember, I think I did this the day before or yesterday. If you do GCF, all right, parentheses, and you put all these numbers in 3, 33, and 54, you can see the GCF is 3. And then the other thing you see in here is that there's an X that comes out of each one of these. So not only does a 3 come out, a 3X comes out. And if I take it out, I'm going to be left with x cubed. All right, minus, okay, if I take a 3x out, I'm left with x squared. Then if I take a 3x, it's going to be negative 11x. Then if I take a 3x, just think, what is 54 divided by 3? It's 18. All right, and that x went outside, so I'm left with this. Now, I have to have another dimension I divide by, which is x minus 2. So, but I've already taken the 3x out, so I only want to divide this by x minus 2 right here. Okay, now, if I'm dividing that by x minus 2, can I use synthetic? Yes, because it's just x minus a number, nothing else. All right, so here, when I do synthetic division, think if I'm dividing by x minus 2, either set that equal to 0 or think opposite, positive 2. All right, now drop these down, or actually, wait, what do I have to do first? Check my exponents. 3, 2, 1, nothing. I don't need any zeros. All right, so here, my coefficient here is 1. My coefficient here is negative 1. My coefficient is negative 11 right here, and then I have 18. All right, so the next thing I do is I take this and I drop it down. All right, 2 times 1 is 2, and I add. So that gives me positive 1. 2 times 1 is 2, and when I add these, I get negative 9. And 2 times negative 9 is negative 18, in which I get 0. And anytime I'm talking about these boxes or rectangles or something and an area, you should be getting 0. It should be a factor. Okay, so here we go. Now, I divided x cubed by x minus 2. So I'm starting here with this exponent. To write the x's, drop it by 1, and it's going to be x squared. Therefore, this is x, and that's our constant. I need a plus here. All right, so this is our third dimension. This is our height. So originally we had 3x, and we had x minus 2. And in the end, we ended up with x squared plus x minus 9. Basically, what we did using the division, we factored it. All right, we factored this thing right here. And these are the 3 factors of it. All right, moving right along to number 4. The area of a rectangle is x cubed minus 27. If the width is x minus 3, what is the length of the rectangle? All right, think area is just length times width. All right, and if the area is x cubed minus 27, and I know the width is x minus 3, if I divide by the x minus 3, it's going to leave me with the length. Okay, so can I use synthetic division? Yes, I can. All right, you can use synthetic division here. You can also use long division. So I do know I have some students that would rather do long division. Feel free, that's fine. If you like long division better, it always works. All right, so here we go. Now, if I'm dividing by x minus 3, think what goes in the box is the opposite, 3. All right. Now, okay, what do we have to check? We have to check exponents. Okay, so let's think about this. X to the third, I need x squared, and I don't see it, so I need a 0x squared. Then I need an x. Well, I don't see it, so 0x. All right, and then I have my constant negative 27. All right, so here we go. Let's write all the numbers out. It starts out with a 1, then it's 0, 0. I just so happen to have 2 of them, and then that's negative 27. All right, pause the video, see if you can do the synthetic division by yourself, okay? And then come back to it to see if you did it correctly. All right, now we're back. Bring the 1 down. 1 times 3 is 3. Okay, add these, and I get 3. All right, 3 times 3 is 9. All right, and then you add those, and you get 9. 3 times 9 is 27, and when I add it, I get 0, which means this is a factor. Well, it should be. It should be a factor. It should go in there evenly because I'm trying to find the length. All right, so now what I have is I divided by something that was x cubed. So what should this start with? X squared, and therefore that's x. I don't have any negatives, so do pluses. So this is my length of my rectangle. That's the thing that's left. And basically, x minus 3 times x squared plus 3x plus 9 is the length, if I were to multiply that out, would be the area of the rectangle. And you should get that if you multiply it out. Also, it's another way, division is another way to factor. So it factors as x minus 3, and then x squared plus 3x plus 9. All right, number 5, last one here. Which of the following polynomials is a factor? All right, now we can go about this different ways. We can say, okay, let's go put, let's divide. So I can put 1 in here because it's the opposite and divide. I don't need any zeros because 3, 2, 1, nothing. You could go do synthetic division on this. All right. Okay, and we bring down our 2. 1 times 2 is 2. All right, add it, and I get 11. 1 times 11 is 11. All right. And when I add this, I would get, what is that? 16? No, 18, sorry. 1 times 18 is 18. And when I add this, I get 12. I'm focusing right here on the 12. Did that come out as 0? No. All right. So therefore, x minus 1 is not a factor. All right. Now you could keep doing this with other ones. I do want to do 2x minus 1. The reason is, look at it. Is that in the form I can do division by synthetic division? No. I would have to do long division. And you could do long division on it. Let me do it so we can recall it since I haven't done it today. All right. All right. So here, 2x cubed divided by 2x. Here, divide by 2, and I get x squared. X squared times 2x is 2x cubed. X squared times negative 1 is negative x squared. Now remember, we change our signs here, okay, because we're distributing the minus sign. All right, these cancel, but when I add this, that makes 10x squared. All right, plus 7x minus 6. All right, now do it all over again. Take this 10x squared, and you're dividing it by that 2x. All right, so whoops, I didn't divide, so erase that right there. All right, this gives me 10 divided by 2 is 5. And when I subtract my exponents, I'm left with x. So this is a positive 5x. All right, so 5x times 2x is 10x squared. 5x times negative 1 is negative 5x. All right, change my signs. These cancel. And when I add these, I get 12x and then minus 6. All right, do it again. You're doing this 12x right here divided by that 2x. 12 divided by 2 is 6, and the x is canceled. So I'm going to put the 6 up here. So 6 times 2x, all right, is 12x. And 6 times negative 1 is negative 6. Change my signs, distribute that negative sign. The front ones cancel because 12x and negative 12x make 0. And then negative 6 and 6 also make 0. So since I got a 0 here, is 2x minus 1 a factor? And yes, it is. Now, this is one way you can do it, all right? Now, there could be multiple answers here of factors. So you could continue and go and divide. Now, that's a lot of work. Think about the warm-up. What we can do is we can take Desmos, and we could take this polynomial and plug it in. So 2x cubed plus 9x squared plus 7x minus 6. What do you remember we can look at to figure out factors? Well, if you said roots or x-intercepts, you are correct. So I'm going to hit them all. Here's all my x-intercepts. And remember this, if negative 3 is a root, then guess what? X plus 3, the opposite, is a factor. And if negative 2 is a root, like I see, then x plus 2 is a factor. And if 0.5 is a root, that means x, the opposite would be minus 1/2 is a factor. But remember, when we have fractions, what we can do is we can take this 2 out in front. So that's 2x minus 1, which is actually the one that we just got, 2x minus 1. Okay, now let's see. Did x plus 3 show up? Yep, that is a factor. Did x plus 2 show up? Yep, that is a factor right there. All right, so all of those are factors. The other ones, x minus 4 and 2x plus 3, are not factors. So if you actually divide by them, you're going to get something that is not a factor. All right. So this is synthetic division. We can use synthetic division to factor things. We can use it to divide things. We can use it to decide if it's a factor of something. All right. We can also use it in these volume problems as well as these area problems as well. All right. Make sure you brush up. Make sure you know long division because you can always use that. We can't always use synthetic division, but it is an easier and quicker way to divide if we're able to use it.